That's where my Turkish stops. Everything else is in English. All right, I'm very excited, and thank you for the opportunity. I know Saturdays are tough, so many people coming on a Saturday is absolutely fantastic. Generally doesn't happen in any other country. So thank you very much for taking time out of your busy schedule and be here on a Saturday. This is my second time in Turkey, and I'm super excited. Thank you, Altug, for giving me an opportunity to come back and talk again. My name is Arun Gupta, and I work for Oracle, and I'm here to talk about Java EE 7. How many of you are using some form of Java EE today? Ah, sweet, pretty much 90% of you. Excellent. So Java EE 7 is the latest version of the enterprise Java platform which we are working on today, and I'm here to talk about what cool things are coming in Java EE 7. The two big themes around Java EE 7 are, we want to boost your productivity, making you more, highly productive with the platform. And then we are also embracing a lot of HTML5 technologies in there. So my goal is to kind of cover what's coming in there and give you an overview of those technologies. And time and Altug permitted, we can show some demos. This is the only marketing / legal slide that we are required to put as part of Oracle, saying that any dates that I say here can always change, so don't sue me for that. Now Java EE 6 was released on December of 2009, so over 3 years ago. Huge changes and improvements made to the platform itself. There are 40 million plus downloads of the platform itself. Lots of cool features such as lightweight EJBs, JSF embracing facelets. You saw some cool demos by Kagate on Prime Faces. How we have dependency injection as part of the platform. So a lot of cool features as part of Java EE 6. And the best part about that is you can keep using Java EE 6 APIs and deploy to an application server of your choice. So whether it's Glassfish, JBoss, or Tommy, or whether it's WebLogic, WebSphere, you have a wide variety of application servers that are available to you. By no means we are restricted to one application server. So today, there are, for example, 18 application servers that are Java EE 6 compliant. So you build an API, build your application to an API, and you can deploy on any of the application servers. Now with Java EE 7, of course, we are going the next level, wherein we want to boost your productivity. We realize people use lots of different frameworks, so we're trying to embrace some of that functionality as part of the platform itself. First of all, we're making you write less boilerplate code. The code that you write again and again, using more dependency injection in the platform, so that the platform or the runtime itself can do a lot more for you, and you don't have to do as part of your application code. That's boilerplate. That's what the runtimes are good for. We're gonna give you a lot more richer functionality. So specifications like batch. Now you can do batch applications as part of the Java EE platform instead of relying upon a third-party library. We're giving you a lot more defaults. So there will be a default JDBC resource or a default JMS resource coming as part of your runtime itself. You can leverage that to build a lot more portable applications, samples, things like that. In terms of HTML5, we are providing a first-class API to build a WebSocket-driven application. And I'll quickly touch upon that. JSON processing becomes part of the platform as well. And we are also allowing you to do HTML5-friendly markup as part of Java Server Faces. Now this is what I call as the pancake diagram for Java EE 7. It's the weekend time, so pancakes are perfect. My kids love pancake. Now, if you look at this diagram, the one on the left-hand side, the images on the left-hand side are the ones that are already existing into the platform. Now, even in those, the gray ones are the ones that are getting minor updates. So for example, if you see JPA is going from 2.0 to 2.1. EJB is going from 3.1 to 3.2. Now the idea is those specifications did a major revision as part of Java EE 6. We want people to understand them, stabilize it, and doing minor revisions now. On the other hand, JAX RS is doing a major revision. So it's going from 1.1 to 2.0. Similarly, JMS, which is in the yellow/orange box, is growing from 1.1, which was done way back in December of 2003, to 2.0. It's catching up with all the language improvements that have been done recently. On the right-hand side, you see the brand new specifications that are coming as part of the platform. So there is a standard way for doing concurrency in the Java EE platform, which is not permissive, which is not allowed right now in Java EE 6. So you can actually have managed executor threads. Standard way for building batch applications as part of the Java platform, Java API for JSON processing, and WebSocket driven applications as well. Now you notice at the top there is a Java caching API. Now recently, and as recently as like 3 days back, we decided that Java Cache API will not be able to make as part of the Java EE 7 platform. And that's why I'm still keeping it as part of the pancake diagram, but crossing it out. That is not going to be part of Java EE 7 platform. So let's take a look at each of the different JSRs and see what cool features are coming in there. I'm going to give you a quick overview of the JSR itself. How many of you know what a JSR is? Some of you, okay. So to give you a quick idea, now the way standards are created in Java, there are a couple of ways. And the first is the JSR way. JSR stands for Java Specification Request. And what that really means is if somebody wants to create a new standard, they will go to Java community process. There's a process that is defined over there. They'll say, I want to create this standard. They will write up a proposal. They'll pull a set of companies or people together. They'll work on that JSR, so to say. And they will say, okay, how to define the standard. Now that JSR has to go through an approval ballot, etc. You have to implement the JSR. So that's the way you define a standard in the Java community process or in the Java land. Or if you want to implement a feature in JDK, which is the implementation of Java SE, then you have a different process for that. But to create a standard, the typical way is to file a JSR, run the JSR. That means make sure you do the proposals, discussions, prepare a document, implement it, and so on and so forth. Now, Java EE 7, as I said earlier, is an umbrella JSR in the sense it says, oh, this is how the platform needs to look like. Now, as it defines at a very higher level, though, at the platform level. But the platform also consists of lots of different JSRs. For example, JAX RS, which is run as JSR 338, which says, oh, this is how you're going to do a RESTful web service. So if you want to write a RESTful web service in the Java EE 7 platform, this is the JSR that you need to look at. And a quick, easy way to figure out what is it doing is you just Google for example, the JSR number. Just Google for JSR 338, and it'll take you to the page where it shows exactly what the specification is, and other details about the specification. Now, in JAX RS earlier versions, there was an ability where you could create a RESTful endpoint very easily on a POJO. So you will take a POJO, which is a plain old Java object, so just define a class. On the POJO, you put an annotation, say at path, which would say, oh, this POJO is going to be published at so-and-so path. That's the REST endpoint. All the features in the earlier version of JAX RS were focused on actually building a server-side infrastructure. With JAX RS 2.0, we're introducing new capability by which you can invoke a REST endpoint using standard API. So think about if you were to invoke it as part of JAX RS 1.1, then you will have to say, oh, I'm going to create a HTTP URL connection. On that connection, I'm going to set metadata, and then I'm going to fire, oh, call HTTP get, put, post, whatever your HTTP verbs are. With this client API, there's a standard way on how you will invoke a REST endpoint, and I'll show a quick sample of that. We also define message filters and entity interceptors. Those are your standard extension points. So for example, you are sending a request from a client to a server. Now you just want to log the request. How would you do it? Well, you can of course put sniffers, or your network traffic sniffers that can actually log the request, but that's a little bit more native way. What if you want to do it in a JAX-RS way? So that's where we define, you can put in a filter, which is basically an extension point. You put in a JAX-RS filter called as logging filter. You define what the logging filter is going to do, what part of the request is going to log, and you do the job. Or what if you want to encrypt your request and decrypt on the other side? So that way you can put your entity interceptors over there to do the encryption and decryption. In JAX-RS 1.1, again, the request used to be synchronous, in the sense the client will request the endpoint will do the processing. While it's doing the processing, the client is holding still, it's basically waiting. When the server is done processing, it returns the response back, and then the client says, okay, I got a response. Now that model doesn't scale well if you have to handle thousands of requests. So that's exactly where we introduced how you can do asynchronous server side and asynchronous client side. So that's a new feature coming as part of JAX-RS 2.0. We're also adding support for hypermedia, so how you can link the resources together, and some configuration elements as well. So let's take a look at how the client API is going to look like. Now, as I explained earlier, a simple REST endpoint would be just a POJO with a single annotation on it, likely bundled in a WAR file and deployed on a Java EE container. Now, once you have that endpoint ready, you have to know what the URI of the endpoint is, or the REST endpoint is. Once you know the URI of the REST endpoint, then you say, I'm going to create a new client. So you create a client factory and you create a new client. Now, this is an expensive object, in the sense it has all the client configuration, etc., as part of it. So typically you will create the object once and cache it. So once you have the client, on the client you can set the target. Target is a URI that you want to invoke. In this case, I'm saying /order, independent of HTTP host, port, etc. This is the URI which is what matters to you. So you're saying invoke the endpoint, which is /orders /order ID /customer. Now order ID, as you realize, is in curly parentheses. What that means is this is a variable part of the URI. So then you say, I'm going to resolve the template, so I'm going to specify what the value of order ID is going to look like. So let's say this is 10. And then I'm going to add a query parameter to it, which is saying question mark name equals value. The way, if you want to invoke a URL with question mark name equals value, that's a query parameter. So we have an encapsulation for that as part of the API also. Finally, you say, I'm going to make a request, and then I'm going to fire an HTTP GET method on it. So you make a request, you fire HTTP GET, and you know you're going to get a string response back, so you get a string response back. So just like that. So it's a very simple API to invoke a REST endpoint. Now, of course, I'm showing you a very trivial sample, but a lot more complexities are available that allows you to, let's say you want to get the response back in a JSON format, or in a different MIME type, or you want to plug in your interceptors and filters here. All of that is possible. JMS 2.0, Java Message Service, is a standard way on how you can send and receive, or build a messaging system as part of Java EE. Now, as I said earlier, JMS was last revised in December of 2003. That's almost 10 years ago. That's long back. Any guesses what was the JDK version at that time? It was not even JDK 1.4. When JDK 1.4 was released after December 2003. So think about all the JDK improvements that have come in since then. Generics, annotations, all that, all that has come after JMS was last revived. So what we are doing as part of JMS 2.0 is primarily a catch-up game. We're catching up, okay, these are the new specifications, or these are the new improvements in the platform, or in the language. Let's make sure we we leverage all of that and improve JMS, so that focusing back on the Java EE 7 theme, so that you have to write less boilerplate code, and I'll show you why it is important. We use dependency injection pretty heavily which is what enables us to write less boilerplate code. There are new features in JDK 7, for example, auto-closable, by which, let's say you open a resource, say file or a connection, you don't have to explicitly close it. As soon as you get out of scope, the JDK runtime automatically closes it for you. So we're leveraging all of those features to making JMS a lot more efficient for you. So let's see, this is a code. Don't try to read it, it's not meant to be readable. So, but this is the code that you will have to do to send a message using JMS 1.1. Three big problems with the code by itself. Well, first of all, you have to create application server specific resources. So somebody needs to explicitly create those resources before the application can even run. Second, there's a lot of boilerplate code. My ultimate goal here is to send a message. Why do I have to write so much boilerplate code? Well, this is basically to honor the API. That's how the API was structured in 2003, or actually it was finalized in 2003, but the API was created a while back. So a lot of boilerplate code that has to be written. Finally, I have to do a lot of exception handling. Oh, what if my connection is not closed, and what if it is not open and it throws an exception, things like that. Now there are a lot of improvements in the platform that allows you to handle that automatically. There's some default behavior, just do it. I'll worry about it if I need to take care of it. With JMS 2.0, so all of that code is drastically simplified. So all this code, as I showed here, is literally cut down to these few lines here. So I'm saying inject, there's a new object that we're introducing in JMS 2.0 called as JMS context. So we're saying inject a JMS context. So you don't have to say new JMS context, etc. You say inject as part of the JMS runtime, part of Java EE 7. This context is automatically injected for you. Now JMS context essentially encapsulates your producer and consumer, so you can create producer from it very easily. If I don't specify what JMS context to inject, there's a default connection factory that is introduced as part of the Java EE 7 platform. Again, less boilerplate code, things which are obvious which needs to be done anyway. You can look up a resource, which is a demo queue, for example, in this case. And then finally you say, on the context, create the producer and send a message to the demo queue with the payload. So very simple. Once again, of all these about 20 lines of code, they come down to like really 4 to 5 lines of code here. So extremely simplified. The biggest improvement in that is it allows your code to be much more semantically readable, in the sense that the moment you look at the code, you know what it's doing. In contrast, if you look at this code, you really have to look through the code and try to figure out, read the comments, oh, this is what the API is doing. Why is it doing this? Things like that. This code, a lot more maintainable, a lot more easy to understand, a lot more easy to pass on to somebody else who's going to maintain the code. A new API that is getting added as part of the Java EE 7 platform is for JSON processing. Now, today, if you were to do JSON processing, you will bundle third-party libraries. And that has worked well, but it adds to an unnecessary footprint to your application. With this, the Java API for JSON processing is going to be part of the runtime itself. We're going to define the API is going to define how do you generate or parse JSON structures very easily. Now, there are two APIs that are being defined, even for parsing and generating. There is one, a streaming API, which is more event-driven, in the sense, show me when the JSON object is starting, or show me when the JSON object is ending, or show me when the name of the JSON object is starting. So I'm going to be event-driven, things like that. So that's one API. The second one is more DOM-driven, which is like an object model. So you say, create this object, within this object, create this object, so on and so forth. So those are the two big APIs, standard mechanisms that we are introducing as part of the JSON processing. The easier one, which is like, take a Pojo, on the Pojo, put an annotation, and generate JSON out of it. You figure out what the properties are, you do the introspection, you automatically do the mapping, which property gets mapped to what name and value, etc. that is coming in a later version. So if I were to show you a simple sample here, for example, this is a simple JSON structure at the top right here. It says first name is John, last name is Smith, age is 25 actually. And then you give a phone number, and it's an array of 2 elements over here, which are again name value pairs as a matter of fact. So here, if I show you the streaming API, you get a parser. By looking at this object, first of all, you get the parser. On the parser, you iterate over it. This parser, of course, is created by looking at the JSON object. Once you read the JSON object, you get the parser on it, and then you iterate over it. So you say, okay, give me the next event. Give me the next event. So in this case, for example, I've said next, next, next. I've called it thrice. So this is my first event, this is my second event, and here's my third event. So it's going through the 3 events, and then this is where the parser is available right now. When you say parser.getString, it returns you the actual value of the first key value pair. Java API for WebSocket. Now, how many of you know Websockets? Some of you, okay. So Kakate once again kind of showed a simple sample of what WebSockets really are. Now, WebSockets is all the craze these days, and the reason it's all the craze is because it allows you to write bi-directional application over the web. If you're using simple HTTP, then the HTTP model is you send a request from client to endpoint. The endpoint is processing something, and then it returns a response back to you. So it's unidirectional. That means client goes to server, server sends a response back to client. And it's a well-defined design pattern, request, response, things like that. Now, lots of limitations with that. First of all, it's very chatty in the sense, if you want to just do a simple hello world, you have to send lots of HTTP headers. You get a response back, a lot of HTTP headers. So that doesn't allow you to scale. It doesn't make you, what if there are hundreds of thousands of, hello worlds coming? That's going to bring your server down, and your client, is not going to scale very well. It cannot be real time. If you think about online real time games, you cannot use HTTP for that. Other part is, every time you're sending a HTTP request, you are first of all setting up a TCP connection. On the TCP connection, once that TCP connection is set up, then you create a HTTP connection. Then you're sending all those, junk headers. Well, not junk headers, but lots of chatty headers. And then once the response comes back, all that goes away. The next request, the whole thing starts all over again. So it's a brand new TCP connection, HTTP connection, headers every time. So that doesn't scale well for real-time applications on the web. And that's exactly what is being served by WebSockets. Now, WebSockets, how they solve it is, WebSocket provides you a duplex channel, which allows you bi-directional communication over a single TCP connection. So the idea is you have a single TCP connection. You start a HTTP connection on that. Now, HTTP specification itself defines how you can upgrade a connection from HTTP to a different protocol. The original intent was, yes, you want to upgrade from simple HTTP to maybe HTTP, a later version of HTTP or HTTPS. But that's the mechanism that HTTP or the WebSocket specification has used, saying, okay, here is a simple TCP setup, here is a HTTP on it, we're going to upgrade that connection from HTTP to WebSocket. Once that upgrade happens, on the same TCP connection, you can, between the client and server, you can exchange infinite amount of messages. No TCP connection creation and tear down, for each of those messages. That's one part of it. Second part of it is the client and server. They're only client and server from the connection perspective. That client initiates the connection and server receives the connection. But once the connection is made, they're actually peers. In the sense, client can send as many requests, server may not respond back, and then similarly, server can send as many requests, client may not respond back. So there is no well-defined request-response pattern. You build the request-response pattern on it. which is what gives it the asynchronous nature. That means client can send burst of messages, server can send burst of messages, and then you interpret the meaning out of it. So I think that's sort of the beauty of WebSocket messages, because it's less chatty, it's single TCP connection, it's bidirectional, and it's full duplex. Client and server can talk to each other without waiting for each other. Now, Java API for WebSocket will define how you can write a WebSocket-driven endpoint very easily as part of the Java E7 platform. There's going to be an annotation-driven approach, and there is an interface-driven approach as well. Now, the standard way people build WebSocket-driven applications is, you have, for example, a JavaScript front end to a WebSocket endpoint. As part of Java API for WebSocket, we'll define a standard API for Java client as well. So let's take a simple sample. If you take a look at the code, which is only in the black, so it's just a simple POJO, public class hello bean, public string hello, say hello, take a parameter, return the value back. If I were to convert it into just a WebSocket endpoint, all you do is you just add the annotation saying at WebSocket endpoint. Of course, your WebSocket endpoint has to listen at a particular URI, so that's the URI that you specify over there. Now that's good, but once the request comes in, how do you know which message needs to be invoked or which Java method needs to be invoked? So you identify that method by putting the at WebSocket message annotation. So the request comes in, this message gets invoked, you do your business logic, you return the response back if you want to return the response back. You can very well make the return type as void, and which is perfectly fine. Now, if I were to show you the simplest possible chat server, literally in a matter of few lines, this is how it would look like. So here I'm saying public class chat bean, this URI where the endpoint is listed is at /chat. I have lifecycle callbacks that whenever a WebSocket connection is open, call this method. That is identified by putting the at WebSocket open annotation on a particular method. Similarly, connection is closed, call at WebSocket close. The method parameters identify which client is initiating the connection or terminating the connection. So you can easily identify that. Now, notice in this case what we are doing is, as the connection is initiated, I am storing it in a set. As the connection is terminated, I'm removing it from the set. So the simple thing for me in order to transmit the message to all the clients that are listening is, every time a message is received, just shoot it to all the clients that are actually invoking the endpoint. So literally in a matter of 10 lines, you have written a full-blown chat server. Now agreed, it can be a little bit fancy. You can start playing around with the messages, but this will get you going. And I'll show you a sample of this hopefully. Bean validation again, is one new specification that was added as part of the Java E6 platform. This allows you to specify validation constraints on your bean. For example, let's say you have a bean or a JPA entity which you are using to persist to the database. Now, in the bean or in the entity, let's say you have a field name and you don't want the name to be more than 30 characters. Well, there are multiple ways by which you can do the validation. You can do when you are populating the bean, before populating the bean, you can validate it. Or once the bean is populated, before you are persisting, you can do the validation. Maybe the input is coming from a user interface, then you can do the validation in JavaScript. So there are different layers where you can do the validation. If you don't do the validation, the data goes to the database. It anyway throws an error back. But it depends, where you are doing the validation. That's the important part. But what bean validation provides is, on the JPA entity itself, if you put the annotation constraint saying at size, say 30, that's it. You just put that single annotation. So that bean validation is automatically integrated with the JPA layer. What that means is, every time you try to persist that JPA entity, the bean validator, which is what the Hibernate validator actually doing it. So Hibernate validator will kick in and in saying, oh, you're trying to persist the entity, let me validate the constraints. If the constraints are not met, I'm going to throw an error back. So again, once again, this improves the semantic readability of your code. You look at the JPA entity, you know exactly, oh, the constraints are this, 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 and if they're not going to be met, it's going to throw an error back. Lot more improvements happening in bean validation as part of the Java E7 platform. For example, instead of specifying on a JPA entity, you can specify that as part of your POJO method. So here, for example, I'm saying public void place order, and I'm specifying two constraints on my first two parameters. I'm saying I don't want the product name to be null. I want the quantity, of course, not to be null, but I want it maximum to be 10. So those are my built-in constraints. Or my third parameter, which is say string customer, I can define a custom constraint in that case. And in the custom constraint, I can exactly define what the constraints are going to look like, which is basically a POJO class where you define how the constraint is. Sorry. And then if you see the last method, in that case, all I'm saying is add future. What that means is when the date is being returned as part of this method, the date should be in future as per the current JVM timestamp. So simple annotation, but once again, the key part is, you see, if you look at the code, there is no need to put a comment over there. The code itself says what it is. The code itself becomes a comment that way. So I think that is a very, very important aspect when you are writing code, whether you're fresh out of college, whether you are 20 years of experience, when you're writing code, I should be able to look at your code and say, it's readable. It's a joy to read the code. Instead of, you get a code and you just hold your head, it's, oh man, it's going to be terrible. Batch applications for the Java platform. That's the new functionality that we're adding as part of the Java E7 platform. We know exactly what batch is good for. Typically non-interactive, bulk-oriented applications. Think of, at the end of a month, your bank statements are generated, for example. There is no need to generate those bank statements during the peak bank hours. It could happen, sometime midnight when the bank is closed, for example. So, and it requires a lot of data processing because it's going to process through like maybe thousands of accounts or hundreds of millions of accounts from your bank and then generate the statements, which it could be again, not just compute intensive, but disk intensive in case of generating PDFs, sending emails, all that stuff. All that can be very easily done as part of batch processing. So what are we doing? Now, there are key concepts here of batch processing. For example, there is a job that needs to be done. The metadata about the job is stored in the job repository, which is at the bottom here. Once the job operator, which is right here, job operator picks a job from the job repository. A job has multiple steps, and a step, is defined as, a chunk. In terms of chunk, what I mean is you have a reader, a processor, and a writer. And I'll show you what exactly those three different steps really mean. Now, how do I define a job, first of all? Well, the job is defined as a job XML, and as the XML language. Now, of course, there are corresponding annotations for that as well. But let's say I want to define a job which is going to send the monthly statements. I'm defining it as a chunk. There's a reader, processor, writer. Let's see what that means. Now, reader really means is going to read account information from the database. Processor means it's actually going to calculate the balance. And writer means it's going to actually send the statement. The way this loops work is you're going to read an account, you're going to process the account, you're going to read an account, process an account, read an account, process an account. Maybe you have done 10 of those, and then you batch them and say send email to 10 of those. So in this case, I've given the chunk size as 10. So read process cycle happens about 10 times, and then once the write cycle happens. Now, what those reader, processor, and writers are, those are effectively my Java classes, which are annotated with the appropriate annotations. So I have an account reader class where I say read account, which this is the method that is identified, which is going to be called as reader. I'm reading an account using JPA. I'm processing an account. So the account which is read here is passed as a parameter here automatically. This is where I'm calculating the balance. And finally, I'm passing a list of account where I'm just sending a bulk email, for example, maybe using Java mail. So that's how jobs would be, batch jobs can be handled. And of course, in terms of job operator, you would say, oh, start the job using this XML and things like that. So all that syntax and semantics are defined as part of the batch JSR. Now, in terms of JPA 2.1, as I said, JPA itself went through a major overhaul as part of Java EE 6. This is a minor release in Java EE 7. Some of the key features that are coming in there, for example, is schema generation. That means how you can take a look at the JPA entity and automatically generate schema from it, either in the database or as DDL scripts. Now, typically, you do not generate your production database as part of application deployment. So the way it works is, you would take, during the development itself, you will create a JPA entity. From the JPA entity, you will say, oh, generate my DDL scripts, which is my data definition language. You'll generate the DDL scripts. You will tune those DDL scripts, and then you can bundle those DDL scripts as part of your WAR file, which could then create the database. So things like that can be very easily done. We have other features like unsynchronized persistence context. Now, persistence context is exactly the way how you manage, the scope of JPA entity. So you say, oh, this is my JPA entity. I want this JPA entity to be stored. So you invoke a method on the persistence context, which is then tied to an underlying data store, which is a RDBMS or maybe a NoSQL data store. Traditionally in JPA, that persistence context is always synchronized. So that means every time you ask persistence context, it just writes to the data store right away. But there are certain cases where you may not want that to happen. So then you can have an unsynchronized persistence context, and that's a new feature added in JPA. Servlet is probably, Servlet is actually one of the oldest specifications as part of Java EE. Now, Servlet 3.1 is getting a minor update as well. The first feature that I'm talk about is non-blocking I/O. So let's take a look at the code. Now, this is a do-get method of Servlet, for example. In this method, all I want to do is I want to read some data from a stream, or from the Servlet input stream. Now, this is what we call as a blocking I/O. In the sense, the client is sending data to the servlet. You just keep on reading, and you are blocked till the client has closed the stream. So it's a blocking I/O. Again, problem with this is scalability issue. What if the client doesn't close the stream? Well, it's going to time out and things like that. But that will affect the scalability of your application. So that's the problem with this. Now, with Servlet 3.1, it allows you scalable application by allowing you to do non-blocking I/O. So for example, in my do-get method, I can set up a read listener. That, okay, you know what? There's going to be a separate read listener. It's going to look at the data as and when it's available, and it's going to tell me, oh, data is available, now go read it. So I set up a read listener first of all. Now, read listener, as a matter of fact, has a on data available method. Now, in this on data available, all I'm saying is while input is ready. So the Servlet 3.1 runtime tell you if there is a data coming from the client, only then you execute, otherwise you don't execute. So the idea is, your methods are not blocked, or your threads are not blocked waiting for data to come from the client side. And that allows you to handle more connections on the server side, or do more processing on the server side effectively. Another long coming feature that was required as part of the Java EE platform is creating your own managed threads. Now, Java EE explicitly restricts that you cannot create threads as part of your Java EE application. Because it's a application, it's managed by a container. If you create your own threads, Java EE container would not know what these threads are good for. Should I shut them down? Should I create them, or should I manage them? Things like that. So as part of JSR 236, which is what we're going to do, is we're going to provide you managed executor threads. Now it completely leverages JSR 166 or the concurrency API as part of JDK. So it just builds upon that and provides you a simple model. So what is going to look like? Well, in your web.xml, you can register a JNDI context. So you'll say, okay, I want a concurrent batch executor. That is your application specific name that you will define and how you want it to look like. And then you'll say, I want an instance of a manage executor service. Now that's the name defined by the specification itself. So if you put that in the web.xml, then on the server side or in your client application code, you can say inject a resource which is concurrent batch executor, and you can tune these properties in the sense you can say, oh, I want a connection pool of 5 threads that should be handily available for my application, or I want the timeout on this pool to be so and so many seconds, things like that. So there are different aspects that you can configure on this manage executor service, and the container will automatically spin these threads for you and give you a thread, and then you can of course execute it. Now as part of Java Server Faces, again JSF 2.0 went through a major revision as part of Java EE 6. In JSF 2.2 we're doing some small features. The first feature that I want to talk about is Faces Flow. That gives you the ability to do flow-based task very easily. What is a flow-based task? Think about in a typical application, let's say you want to do a flow. Flow means you want to go to a shopping cart, then you want to enter your credit card details, then your shipping address, and then you say confirm checkout, things like that. Well, those 4 pages are logically related as a task. The corresponding backing beans should be part of that. Now what if you want to build that functionality and leverage it in another application? Copy paste, of course that'll work, but that's not really promoting dry or don't repeat yourself. That's not really modular itself. So now that technology has existed into Spring Webflow or ADF Task Flow and other frameworks for a while. With JSF 2.2 we are standardizing that. So you can say take all my JSF pages and beans together so that they can be packaged together, bundled as a module, and that module can then be reused across multiple applications. Flow scoped, as a matter of fact, is a new annotation that is introduced in JSF 2.2 that allows you to restrict a bean to a particular scope. And hopefully I'll be able to show you a demo of that. Now, several of these implementations have been integrated in Glassfish. You can download the latest promoted build of Glassfish 4.0. So JSF, Servlet 3.1, JPA, EJB, JAX-RS, WebSocket. Most of these implementations, as I said, are already integrated in Glassfish. So you can try out these features by yourself. Now Java EE 7, that's where it is. Going forward, we're looking at Java EE 8. The big theme that we're thinking over there is going to be cloud to provide a standards-based PaaS programming model. Modularity, multi-tenancy, those are sort of the keywords we are looking at. Of course, we rely a lot upon the underlying JDK for that. They need to provide that feature, and then we integrate, we build upon that as part of the Java EE platform. Now, one of the features that I want to talk about here is called as Adapter JSR. How many of you know about that? Just a couple. Okay, excellent. I think good audience that way. Now, Adapter JSR is a program that was started primarily by London Java community. The idea is to increase the grassroots evangelism for different JSRs that are available in the community. And the idea is, as a JUG, as a Java user group, you can say, oh, I'm interested in WebSocket, or I'm interested, this is pretty cool, this is cutting edge, it's going to look good on my resume, so I'm interested in WebSocket, learning about it, see how it's getting supported. So I'm going to download the spec, and I'm going to try out a simple sample, I'm going to build an application, I'm going to take a look at the Java docs, things like that. And then I'm going to provide feedback to the expert group, or I'm going to file bugs, things like that. So very simple stuff, nothing fancy, but the idea is as a JUG, say for example Altug is here and he says, okay, we're going to do that as a JUG, then your JUG is effectively adopting that JSR. By no means you need to restrict yourself to one JSR. It could span across multiple JSRs, but the idea is we want to make sure, first of all, that you understand the technology, You are the experts. You are using the technology day in and day out. So we want to get your feedback before the technology goes final, so that we can actually incorporate that feedback and make sure the technology serves your use case. As a matter of fact, this list is a little bit old, but there are about 20 jugs around the world that are already adopting different JSRs. There are jugs from Southern America, which is like Java, for example, from Sao Paulo. There are jugs from India, like Chennai and Hyderabad. There are jugs from the US, like Silicon Valley jug or Chicago or Houston jug. Or there are several jugs from the Europe region. There is a Belgium jug. There are jugs from Africa, like Congo jug. So all these jugs are taking a single JSR or a bunch of JSRs and doing the things that I talked about earlier. So if I were to quote a simple example, for example, of a Chennai jug, on Chennai jug, what they're doing is they have taken in Chennai jug, they have taken like 5 different JSRs. They're building an application, end-to-end application, which allows you to understand how the different technologies work with each other. And as part of that, not only they are downloading the specification, trying out the implementation, they're also actively filing bugs. You can actually, we will provide you the material. You can take the material off the slides, give a presentation at your local jug. So there's a lot of active discussion happening around this topic right now in the JCP community. So I think if you want the local jug or the Istanbul jug to be visible at a global level, I think this is a beautiful opportunity. You should not go. Go harass Altug that we should participate in Adapter JSR. And I'm here today, by all means, happy to help you out. Okay, now let me take 5 minutes to show a demo of some of the functionality that we talked about. So this is a simple application that I built. Now, this is a brand new application that I built, actually. I'm going to be using that at a conference next week. But this is running on, application is built using NetBeans, which already has Java EE 7 functionality now. And it is deployed on Glassfish 4. Okay? So let's say this is your broader application. And we were talking about flows, right? So in this case, this is a movieplex in the sense that you can go look at what movies are there, select a movie, make a reservation. You can chat with other viewers and things like that. So my typical flow, one of the flow in this would be, I want to book a movie. Okay, so I say book a movie here. Excellent. So let's go back to NetBeans and deploy this thing again here. So what I'm using is NetBeans IDE 7.3 RC1. I've just built a simple Maven-based application. Not in 7.3 RC1, but there's another development build which allows you to create Maven-based application using Java EE 7 in NetBeans as well. Here, for example, you go to Services tab. You can configure your multiple servers. And as you can see, I have different versions of Glassfish that are configured here. They're all Glassfish 4.0. Okay, that's my movie thing. All right. So now when I say book a movie, then I'm going into a flow here. Okay. Now in the flow, for example, it's showing me the list of movies. I can pick, for example, say Inception. As I just love that movie. Then I can say pick a time. It says show timings for Inception, what shows are available. I pick a time, say 2 o'clock. Then I say confirm. It says, okay, movie name, inception, starts at this, theater 1. What theater is the movie is running at. Now, here I can say book it. So it says reservation confirmed. So that basically completes my flow. And now I can exit out of the flow. So it goes back to the main page. Now if I look at my NetBeans IDE here, so all the pages that are for the booking reservation are in the booking folder here. So these are all the pages here. Similarly, if I look at my source packages, all the files are in this one here. If I look at my booking flow, for example, I exactly define how my flow is going to look like. I mark what my starting page is going to look like. So here, for example, I'm saying this is going to be my flow definition. And I'm defining what my starting page is going to look like. So this is in the booking folder. I'm saying booking/booking.xhtml. So this is my starting point. So there is a full syntax that is defined exactly how the page is going to look like, what the flow could look like, things like that. Okay. Now, let me show you a different use case here, which is how a chat room could look like. For example, let's say all the people are watching a movie. Now they want a chat room where they can talk about the movie, as if Twitter is not enough. So if I click here, I'm in a chat room now. So let's copy this URL and go to, say, Firefox and run this URL here. Now I go to chat room. So I'm in a chat room here. Okay. So let's say I join here, and in the browser right behind us here it says Duke join. Okay. So let's say here I say Duke 2 join again. So it says Duke 2 join. And in this browser here it's showing me the user list. Now imagine multiple folks are in the theater. They all have their own browsers open. They can all join this chat room, and then now they can start talking about it. So you can say hello, send a message. It says Duke 2 send a message, and that shows up in other window too. And here I can say hi there, send, and that way the chat thing goes on. So this is my simple chat server, but let's take a look at the backend code now. That's the more fun part. Exactly the chat server that I showed you earlier. Very simple code, just a lifecycle callback method, open, close, and down here I have a WebSocket message. Now the code here is a little bit different because all I'm doing is I'm broadcasting. So if you take a look at this message here, this is my payload, which is how the WebSocket message is coming in. The second parameter here says which client the message is coming in from. So all I'm saying is, okay, when you're broadcasting the message, don't broadcast to yourself, broadcast to everybody else. And if I take a look at my corresponding front-end page here, so this is my chatroom.xhtml. Here I have a simple chat log, users, and then I have a bunch of buttons here. Which one of them is to join, which is when a user is joining. So if I click on join here, this is my script here. In my JavaScript, I'm saying, by the way, a WebSocket endpoint, even though hosted as part of a Java EE application server, is hosted at WS:/URI scheme instead of HTTP URI scheme. Okay. So I'm saying go connect to this URI, which is a WebSocket endpoint on this URI, new WebSocket, which is a brand new, which is a new API that is supported in the modern browsers. And then I have my lifecycle callback methods here, on, open, message, error, close, which is like if you receive a message back as part of a WebSocket communication, what do you do, and things like that. Now in join, all I'm saying is grab the value from the text field and send a message to all the different clients that are listening, or to the server actually. Then the server is going to broadcast to all the clients. Similarly, in send message, all I'm saying is send a message to the server. And then the server is again, same thing, going to broadcast to all the clients. So simple methods here. But you get the point. So I would highly recommend to go talk to Altug and see how your Java user group can participate and make Java E7 successful. All the specifications are available, the implementations are available for download. NetBeans IDE integration is there. You can take a look at my blog, and I have several entries over there which explain in detail exactly how Java E7 is evolving and how you can help out, and things like that. And I don't think we have time for Q&A, but I'm here all day. If you have any questions, please feel free to reach out to me. Thank you.